All right, welcome to Unit 7, our last unit of this ACT prep. Trigonometry, okay? We're day 1, we're going to talk about right triangle trigonometry. Okay, so right triangle trigonometry deals with angles less than 90 degrees. The trigonometric functions are ratios of the sides of right triangles. Here's the familiar right triangle with the names of the legs labeled. So if you're standing at theta, okay, the biggest thing people mess up about right triangle trigonometry is labeling their sides, because the names of the sides will change depending on which acute angle that you are reading the triangle from. If I read my triangle from this theta, from this acute angle, this side would be adjacent to me, this side would be opposite of me, and then this, of course, would be the hypotenuse. But I can draw the exact same triangle, and in right triangle trigonometry, you can perform trig from either of the acute angles. So let's call this alpha. If I'm standing up here at alpha, then I read the triangle different. This would be the opposite side, this would be the adjacent side, and then of course this would still be the hypotenuse. But you got to be careful. You got to make sure that you're reading the triangle and you're labeling your triangle from whatever acute angle that the problem is asking you to do trig from. Okay? But once you have your triangle labeled properly from whatever acute angle that you're working from, then sine of theta is the length of the opposite side over the length of the hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite over adjacent. Most famous reindeer of all, just kidding. The most famous mnemonic, if you will, to memorize these ratios is Soh-Cah-Toa. Okay, sine is opposite over hypotenuse. Ka is cosine, which is adjacent over hypotenuse. And tangent, which is opposite over adjacent. So if you can remember Soh-Cah-Toa, you'll remember which sides form the ratios for sine, cosine, and tangent. Okay? Then you have the cousins. I call them cousins. They call them properly inverse trigonometric functions. Okay? So these 3 trigonometric functions are inverses of the previously mentioned 3 functions. And you should also memorize those. Cosecant of theta is basically the inverse of sine. So it's the reciprocal of sine. So because sine theta, oh my goodness, sine theta is opposite over hypotenuse, then cosecant, again, we just flip this over, would be hypotenuse over opposite. It's just the reciprocal. Okay, so secant of theta is the inverse of cosine. So basically you just take your cosine and you flip it over. If cosine theta is adjacent over hypotenuse, then secant, its inverse, flip this over as hypotenuse over adjacent. Cotangent of theta is inverse to tangent. So you just take the tangent ratio and flip it over. So tan theta is opposite over adjacent, and you can see that cotangent is just this flipped over. Okay? You can also measure angles, and you can either measure them using degrees or radians. So sometimes you're going to have to convert between radians and degrees. And your conversion rate is your radian measure is equal to pi divided by 180 times your degree measure. Okay? They're saying it's also helpful to memorize these, and that's true. Okay, the most common, I don't know, most common, but most popular angle measures are 0, 30, 45, 60, and 90. And again, they want you to memorize these. The sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. Sine of 30 is a half, cosine of 30 is square root of 3 over 2, tan 30 is square root of 3 over 3. And the 45 degree angle, and the 60 degree angle, and the 90 degree angle. I think it's easier to memorize these with the unit circle. But we're not going to get to the unit circle for a couple of days. So, again, yes, you should have these memorized because they're going to come up a lot. But I think it's easier to memorize them with the unit circle than it is just to memorize this chart. So when we get to that later, I'll bring this up again. All right, so some examples. It wants me to find the sine, cosine, and tangent of angle theta. So again, they're telling me I'm working from theta. So first thing I do is label my triangle. From this perspective, this side is adjacent, this side is opposite, this side is the hypotenuse. Once you got that done, you can do Soh-Cah-Toa. And then I go ahead and do, if I do cosecant, that's H over O. Secant is H over A, and cotangent is A over O. Just have those handy, all right? Memorize those, and if you memorize Soh-Cah-Toa, again, just write the cousins underneath it and flip over their ratios. Okay, so for sine, it would be opposite my theta, which is 3, over my hypotenuse, which is 3 square roots of 5. Cosine would be adjacent, which is 6, over hypotenuse, which is 3 square roots of 5. And tangent would be opposite, which is 3 over adjacent, which is 6. Your cosecant would be hypotenuse over opposite, so that's going to be 3 square roots of 5 over 3. Secant, again, I'm just going to go up here and flip them over. Secant is reciprocal to cosine, so since cosine was 6 over 3 square roots of 5, secant is 3 square roots of 5 over 6. And since tangent is 3 over 6, cotangent, flip it over, is going to be 6 over 3. Now, unfortunately, we're not done because you cannot leave radical. You need to simplify them. You need to reduce them to simplest terms if you can. And you need to eliminate any radicals in the denominator. So first of all, I notice that 3 cancels 3, which gives me 1 over the square root of 5. And then to rationalize, I'm going to multiply the top and the bottom by the square root of 5, and I get the square root of 5 over the square root of 25, which is just 5. There's my sine. Cosine, again, I'm going to reduce. 3 goes into 6 twice, so that gives me 2 over the square root of 5. Again, I have to rationalize, so multiply the top and the bottom by the square root of 5. I get 2 square roots of 5, again, over the square root of 25, but that's just 5. No, you cannot cancel the 5s. One's in, one's out. You can't touch them. 3 over 6 just reduces down to 1 over 2. So on this one, to simplify, the 3's cancel, and I'm just left with the square root of 5, and I don't have to rationalize. Yeah? Okay, the cosine, again, this 3 goes into 6 twice, so I end up with the square root of 5 over 2, and again, the radical's on top, so I don't have to rationalize. And then cotangent, 6 divided by 3 is 2. Done. Okay. Alright, so try this one. Hit pause. Come back when you're ready. And hopefully you got 3/5. In the triangle below, what is the sine of theta? Dang it. What is the sine of theta? So they're telling me I'm here. So if I label my triangle from here, this is opposite, this is adjacent, this is hypotenuse. Well, sine theta is opposite over hypotenuse. Well, I know opposite, but I don't know hypotenuse. Well, it's a right triangle, so I can figure it out using Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. So you get 9 plus 16, which is 25, equals hypotenuse squared. Square root, and I get the hypotenuse is equal to 5. So sine is 3 over 5. Yeah? Alright, try this next one. Hit pause, come back when you're ready. And this always amazes me, and this is typical of ACT. We just went through all those examples, and I followed the book and did it in the order they did it, and then they throw this in here, and they did not give you a single example like it. Just like that. All right, in the figure below, the base of the ladder is 3 feet from the house. If the ladder forms a 79-degree angle with the ground, what is the length of the ladder? So I'm going to redraw that. You got this right triangle here. This is 79 degrees. This distance is 3 feet, and they want me to figure out the length of the ladder. Well, what you're going to do is they still gave you an angle. So this is where you're working from. This is where you're reading your triangle from. So this is adjacent, and this is hypotenuse. Soh-Cah-Toa. I got to figure out which function is going to give me what I need. Well, I need the function that uses adjacent and hypotenuse. So I need my cosine function. So I set it up, which is going to say cosine of 79 degrees is equal to adjacent over hypotenuse. Okay? So I'm going to try and get x alone. So first thing I'm going to do is multiply by x on both sides to get it out of the denominator. So that's going to give me x times cosine 79 degrees equal to 3. And now to get x alone, I'm going to divide by cosine 79 degrees. And I get x equals 3 over the cosine of 79 degrees, which is not one of my answers. So that's why. I was like wondering. No, I wasn't anyway. All right, they're like, why are they giving me all that information? Well, because I need to know. Now, they gave you all three so they wouldn't tip you off as to which one to use. I'm using cosine, so I need to know the value of this, which they tell me is 0.191. Now, your calculator would work, obviously. You can just make sure you're in degrees and type it in. But cosines, your trig functions are decimals that are really, really long. Okay, so when they give you your values, use theirs because they've rounded it off to where they want it rounded off, which will get you the right rounded off answer. If you use your calculator, you might be off a little. It shouldn't be much, but you might be off a little. It won't be exact because your rounded off value would be whatever the calculator decided, not what they decided. They want you to use this decimal equivalent. So x equals 3 divided by 0.191. And if you type that in, you get x equals 15.7068, blah, 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 blah. They want to the nearest hundredth, so tenths, hundredths, break, 6 bumps it up, and that's where they got the 15.71. Okay? All right, so some more examples. They want me to find all 6 of them. Well, I'm going to do it in a little bit of a different order than they did it. Okay, well, I'll do it in the same order, but, okay, number 1, they want sine theta. So they're telling me I'm working from here, which makes this adjacent, this opposite, and this hypotenuse. Well, sine, again, if you put your little thingies up here, I have Soh-Cah-Toa, and then underneath, I'm going to do my cosecant is hypotenuse over opposite. I can't read that. Your cosecant is hypotenuse over opposite. Your secant is hypotenuse over adjacent. And your cotan is adjacent over opposite. So I just always write those at the top of whatever I'm working on. It makes my life a lot easier. So number 1, I'm going to do sine theta, which is going to be the opposite, which is 10, over hypotenuse, which is 12.5. Type that in a calculator, and you get 0.8. Math enter it, and you get 4/5. Because they usually want their ratio in a fraction form, not a decimal form. Okay, so there's 1. My cosine, number 2, cosine theta, is going to be adjacent over hypotenuse, which is 7.5 over 12.5. When I type that in, I get 0.6. Math enter it, and you get 3/5. Okay, then if I do tangent theta, it's opposite over adjacent, so opposite is 10, adjacent is 7.5. Type that in, I get 1.3 repeating. Math enter it, you get 4/3. So now to do the cousins, All right, number 4, they want cosecant theta, which is going to be, again, you're just flipping it. You're doing hypotenuse over opposite. So that's going to be 12.5 over 10, which when I type that out, I get 1.25. Math, enter it. I get 5/4. Oh, look, they're reciprocals to each other. Amazing. 5, they want secant theta. Secant is hypotenuse over adjacent, so that's 12.5 over 7.5. Type that in, you get 1.6 repeating. Math, enter it, you get 5/3. Oh, look, they're reciprocals to each other. Amazing. And then my cotangent theta. Cotangent theta is adjacent over opposite, so that is going to be 7.5 over 10, which gives you 0.75. Math, enter that, you get 3/4. Oh, look, they're reciprocals to each other. Amazing. Okay? And then they're going to love to give you tricks. They're going to give you one trig function and then ask you to find another one. The easiest thing I do is draw a triangle every time. Call it theta. They're giving you tangent. Tangent is opposite over adjacent. So they're telling you that opposite my theta is 5 and adjacent is 12. They want me to find sine, which is opposite over hypotenuse. So I need the hypotenuse. So Pythagorean theorem tells me that 5 squared plus 12 squared will equal my hypotenuse squared. So that is going to be 25 plus 144 is 169. Square root, and my hypotenuse is 13. So sine theta is going to be opposite over hypotenuse, which is 5/13. So sine theta equals 5/13. Okay? If cotangent of theta equals 15/8, cotangent is reciprocal to tangent, so it's adjacent over opposite. So again, if I draw my triangle, put theta there, adjacent to me is 15 and opposite is 8, and they want cosine, which is adjacent over hypotenuse. Well, I know adjacent is 15, but I got to figure out my hypotenuse again. So I have 8 squared plus 15 squared equals hypotenuse squared. This is 289 equals hypotenuse squared. Square root, I get my hypotenuse is 17. Goes on the bottom, so cosine theta is 15/17. Okay? Number 9. It says if sine theta is 12/13, then cosecant. Well, sine is opposite over hypotenuse, and cosecant is a cousin. Reciprocal is hypotenuse over opposite. So I don't even need a triangle for this one. You're just going to flip it over, 13/12. So cosecant theta would be 13/12. Don't do more work than you have to. Okay? 10, if secant theta is 3/2, then sine theta is 1. Secant is reciprocal to cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Sine is opposite over hypotenuse. Well, I know the hypotenuse, but I need opposite, so I'm going to draw me a triangle. There's theta, and I know that the hypotenuse is 3, adjacent is 2. I need opposite. So I can do opposite squared plus 2 squared equals hypotenuse squared. So that gives me opposite squared plus 4 equals 9. That gives me opposite squared equals 5, square root. And my opposite side is the square root of 5, which goes here. And on top is fine. I don't need to rationalize. So I have the square root of 5/3. Okay. All right. You try one. Hit pause. Come back when you're ready. And hopefully you got 15/12. It says they want secant. secant is reciprocal to cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So secant theta, the hypotenuse is 15, adjacent is 12, and there you go. Which I'm surprised they didn't reduce that. 3 goes into both of those. I would have thought they would have put it 5/4, but beware of that. They may or may not reduce. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 5.03. All right, in the triangle below, what is the length of side A, which is, if I'm working from this angle, that's opposite, and this is adjacent, and this is hypotenuse. What is the length of side A rounded to the nearest hundredth? Well, from this, again, I'm looking for opposite. I don't want to use hypotenuse because I don't know that either. I got to use something that I know. So I want to use opposite and adjacent. That would be the tan function, because tangent is opposite over adjacent. So I'm going to set up tan 40, because I know the angle, is opposite, which is A, over adjacent, which is 6. So to get A alone, all I have to do is multiply by 6. So 6 times tangent 40 equals A. That answer isn't there. Oh, that's why they gave me this stuff. I need to replace this with its decimal equivalent. They gave me all 3 so that I wouldn't figure out which function to use by their hint. So I'm going to say 6 times 0.839 equals A. And you type that in and you get A equals 5.034 blah 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 blah. It wants the nearest hundredth, 10th, hundredth. The 4 won't do anything. So I keep 5.03. Okay. All right, try this one. Hit pause. Come back when you're ready. And hopefully you got, come on, 25/7. Sine and cosecant are reciprocals to each other. So if you know sine, all you got to do to get cosecant is flip it over. Done. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got H. In the figure below, a rope is run from the top of the pole to the ground. The rope is 40 feet long, and it forms a 50-degree angle with the ground. What is the height of the pole? So from this angle, they want opposite, and they gave me hypotenuse. That's a sine function, opposite and hypotenuse. So I'm going to set up sine 50 equals opposite over hypotenuse. I've got to figure out that opposite sign, so to get, or opposite value, so to get opposite alone, I'm going to kill the fraction, so I'm going to multiply by 40, and I have 40 times sine 50 degrees is equal to the opposite side. Well, that answer isn't there because they substituted the decimal equivalent for sine 50 in, which they told me to use 0.766, which will give me my opposite side equal to 30.64. Okay. All right, try this one. Hit pause. Come back when you're ready. And hopefully you got D. Says an airplane takes off and climbs at a 30-degree angle to an altitude of 20,000 feet. To the nearest foot, what ground distance will the plane have flown when it reaches 20,000 feet? So from this angle, I'm looking for adjacent, and they gave me opposite. The function that uses opposite and adjacent is the tangent function. So I'm going to say tan 30 degrees equals 20,000 over the adjacent side. Well, I'm trying to figure out what the adjacent side is, so I've got to get adjacent alone. So I'm going to multiply by adjacent, and I get the adjacent side times tan 30 equals 20,000. To get adjacent alone now, I'm going to divide by tan 30. And my adjacent side will be 20,000 divided by tan 30, which I need a decimal equivalent for, which they told me was 0.577. So I replace this with 0.577, type it in a calculator, and I get 34662.045, blah, 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 blah. It's said to the nearest foot, so they want it at the nearest whole number. Well, 0 isn't going to do anything to it, so it's 34,662 feet. Okay, and that will do it for day 1 of trigonometry. And I will see you next time for day 2.